Hello everyone, the purpose of this video is to introduce you to lesson number 1. I'll be basically talking about the major component of this lesson, and I'll go over some of the questions throughout this notes. This lesson starts by talking about our senses and their limitations, and it has some examples of how our senses could be deceived by the appearance and how important it is to use tools, measuring tools, especially for example a ruler. If you want to figure out which line here represent the extension of this lower line, most people might think it's the lower line here, but actually if you use a ruler you'll be able to line it up and you'll see it's the extension of this upper line. And the same thing here with the length of those two, and whether those 5 lines are parallel or not. All those are part of the limitation of our senses that require us to use certain tools to overcome those limitations. The second part and the most important part is understanding science and the process of science and the nature of science, and that's the core of lesson number 1. If you read this quote here by Michael Faraday, you'll see that experiment is actually the most important part or the most important component that sets science apart from other disciplines. Science is based upon empirical data that are provided by an experiment, by a controlled experiments. And this experiment has to be repeatable, meaning if somebody else in a different place conducted the same experiment, they'll be able to get the same results that you got. So the fact that the outcome of experiments are reproducible and repeatable is major part of the scientific process. We can summarize the scientific process in 5 steps, but please note that those steps are not linear, meaning you could sometimes jump from one step to another and sometimes go back and so on, flip back and forth between one step and another. But in general, this is the process of science. The first step is to identify the problem, and I give always the example of waking up in the morning, trying to start your car, and your car does not work. Then in that case, you identify the problem to be the car is not working. The second step is looking for information. If you don't have information about any problem, you cannot really proceed to the third step, which is developing hypothesis. Before that, you have to have information. And I always give the example of foreign language. If you don't have any information about foreign language, you cannot really think about it. To give you an example, let me write in a different language here. For example, as you see, I'm writing in a foreign language from right to left. Okay, I'm almost done. Okay, so I wrote something here. I wrote a sentence in a foreign language with foreign alphabets. It's not English alphabets. And if I ask you to develop a hypothesis, which is possible explanation for the problem, can you come up with any ideas with any hypothesis? And the answer is no, simply because you don't have information. Therefore, information is a major part of the scientific process. Without information about the problem, you'll not be able to come up with a hypothesis. Let me write the same meaning of this sentence, but instead of writing it in Arabic, and this is in Arabic, let me write it in Deutsch, in German. Okay, so I'm writing the same thing here, the same meaning, but in German. Okay, so if you try to read what I wrote right now in German, you can see it says Ich studiere Physik. Now, if I ask you the same question, can you come up with a hypothesis? Many of you might be able to come up with a guess here, with an educated guess. Ich studiere Physik means I study physics. And the reason you are able to come up with a hypothesis is because you have information about the alphabets here. The German alphabets basically has the same roots as the English, and there are many similar words. I study physics. While the one on the top here, أنا أدرس الفيزياء, this is in Arabic language, and you don't have information about it whatsoever. so you cannot develop a hypothesis. So information is a very important part of the scientific process. Unfortunately, it's usually left out in science textbook. They usually jump from identifying the problem to developing a hypothesis. Yeah, you should have information about the topic you are looking at before you come up with a hypothesis. If you go back to the car example, identifying the problem, if your car does not start, you cannot come up with a hypothesis unless you know about cars, unless you know the components of the car that are engaged in starting it. So if you don't know, for example, that the battery is part of the components that are crucial to start the car, you'll not be able to come up with a guess about the battery. So again, if you know about cars, you'll be able to come up with several hypotheses. Of course, each time you have to test one hypothesis. So if you assume that the battery is not working, then if that's your hypothesis that the battery is bad. And the step number 4 is to devise an experiment to test your hypothesis. So how can we test the battery hypothesis? To test the battery hypothesis, you can either jump start the car. If the car works, then this confirm your hypothesis. If you have a voltmeter, you can measure the voltage of the battery. Usually the voltage of the battery is around 12 to 13 volts. So if it's above 12 to 13 volts, then your hypothesis is wrong. Otherwise, then your hypothesis is correct and you can come up with a theory. And theory is basically a hypothesis that has been substantiated by the experiment. If your experiment supported the prediction by the hypothesis, then the hypothesis will turn into a theory. Now, if it's not, then you have to go back and develop another hypothesis. So if the battery is not bad, if the battery is working, then you have to develop another hypothesis, like, for example, the alternator is not working or the starter is not working. And each time you have to test one hypothesis. So you have to change the alternator, test it. Then if that does not work, you have to change the starter and so on until you come up with your conclusion, with your theory. Define theory as an attempt to explain why something happened. In that case, for example, why the car did not work. And it often changes as new experiments are performed. So usually theories are not static. They are an attempt to explain why something happened. But it's very much substantiated by the scientific process, mainly experiments. It's supported by repeatable, reproducible experiments. So we have to distinguish between theory and hypothesis. Hypothesis is an educated guess based upon your limited observations, while a theory is a hypothesis that was substantiated by repeatable, reproducible experiments, and all the predictions of those theory met their challenges. Okay, so theory, don't underestimate theory, although they are not facts, they are not static, but they are supported by empirical data. They are supported by experiments. And this is misconception usually here in the media, the term theory. This is just a theory. And this is confusion between theory and hypothesis. Hypothesis is not substantiated by experiment, but theory is substantiated by experiment. So you cannot say that this is just a theory. We have to distinguish between theories and natural laws. As we mentioned, theories is about why something happened. For example, why do we have earthquakes? Why do we have volcanoes? The plate tectonics theory came and explained those phenomena. And it often changed as new experiments are performed. Even, for example, with plate tectonics, it started as a continental drift by Alfred Wegener, and then it was modified and developed throughout the years through experiments in the mid-Atlantic ridge and others, modify it to the model we have right now. Natural laws, on the other hand, is a statement or equation that express an observed behavior. So it summarizes what happens rather than why something happened. Usually it's very much static, although this is not always the case. Meaning once it's established, it usually does not change. That does not mean it never changed, but usually it's more static than theories. Examples of natural law is the gravitational law. Gravitational laws basically tells us the relation between two masses, and that the earth always pulls things down toward the center of the earth. So it's a description of what happens. The law of conservation of energy, it's a law, it's not a theory. It states that energy neither destroyed nor created. There's another term in science we use usually is the term model. And model is representation of something that cannot be directly observed. System, for example, you cannot directly observe your solar system, so we develop a physical model of the solar system. The same thing in the microscopic world. The atoms cannot be directly observed. And models are not necessarily physical models. It could be in the form of verbal statement, like a certain scientific law in a statement, like Charles' law. Charles' law said that the volume of the gas is directly proportional to its temperature, which means that if you increase the temperature of a gas, its volume will increase by the same factor. Model also could be an equation. Mathematical equations are models. You represent the relation between two variables through an equation. Or a graph, which also represents the relation between two variables. So models could take different forms. It could be a physical model like the solar system, developing the anatomy of a human body. You can develop a model for that physical model, or a verbal model like stating scientific laws, or it could be mathematical model in the form of mathematical equation, or a graphical model in the form of a graph. Okay, for the discussion and the homework, make sure you state the 5 steps of the scientific method in question number 1 in the discussion, and question number 1 in the homework. Include the information, and very important that the information has to be related to the problem, and more important than that, the hypothesis has to be based upon the information. When you develop the hypothesis, especially in question number 1, and you'll see similar question in the quiz as well, quiz number 1. So make sure that your hypothesis is based upon the information that you provided, and that the information is relevant to the problem. This is one of the common errors that students miss when they state the 5 steps of the scientific method. And remember that the solution for the homework and the discussion exercises are on Blackboard in the area titled Solution to D and H. D and H stands for discussion and homework. I hope you find this video helpful in helping you start with lesson number 1. Again, you are welcome always to ask questions either via email or on the discussion